Hi, I'm Hassan, the lecturer here at the Institute of Medical Education, and today we're going to take a look at solutions to Section 3 of ACER's GAMSAT Green Booklet, Practice Test 1, specifically Unit 10, questions 32 to 35. So this question, when I saw it, it made me feel warm inside because I actually previously worked in a cancer research lab, so drug design development, where we developed synthetic forms of fatty acids and we tested them in cancer cells to see how they killed the cells. So when I saw this question come up in this unit, I was like, oh, it made me feel great because I'm like, I just blitzed through the questions because it was just second nature to me, I guess. Hopefully in the GAMSAT you do get similar questions like this where in your past you've worked in a similar project or something like that. So you get the question, you don't even have to read the stimulus because you're like, oh, I did this every single day for like the last 5 years. But for those of you obviously not familiar with, say, fatty acids and this kind of chemistry, there is a specific way and a specific formula you can produce to, I guess, identify different types of fatty acids and their saturation. So generally speaking, you're going to have what's called a saturated fatty acid. Those are fatty acids without double bonds. You've got a monounsaturated fatty acid. Those are the ones with one double bond in the system. And then you've got polyunsaturated fatty acids. Those are fatty acids with more than one double bond in the system. So you've probably heard about these good fats, bad fats. I don't like using that term because technically speaking, all fats are good for you, but in moderation. So you hear that the polyunsaturated fatty acids like your omega-3s, they're pretty good for you, but then the saturated fatty acids, the ones you find in like greasy fast food hamburgers, they're bad for you. But if we take a close look at the question, it pretty much gives us a spiel about fatty acids, and it gives us a table of common fatty acids. So what you had to do here was you had to quickly deduce which of these fatty acids are saturated, polyunsaturated, or monounsaturated and polyunsaturated. The easiest way to do that is by using these three formulae. So you're probably wondering, how do you get this formulae? I'll give you a quick example. If we just draw a quick example, let's just say a 5, 1, 2, 3, 4, 5, O, H. Let's draw the hydrogens here. Okay. Oh, there we go. The color's changing, so it's looking nice and pretty, this fatty acid. So you can see in this saturated fatty acid, we've got 1, 2, 3, 4, 5 carbons. So let's write saturated. So we've got carbon count is 5. Hydrogens, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got hydrogen count is 10. And then you've got the O2. So all saturated fatty acids are going to follow this sort of law or this sort of equation or formulae. So you're going to have twice as many hydrogens as you do carbons. But you can see, therefore, if you were to add a double bond to this system, let's just add a double bond here. And then obviously we have to satisfy the molecule. We have to remove, say, a double bond here. And obviously satisfy this side. Let's just say remove a double bond here. What we end up now with is a monounsaturated. So the carbon count is the same. So C is still 5. Your hydrogen count has gone down by 2. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 hydrogens and still 2 oxygens. So if we look at the formula for monounsaturated fatty acids, we still got the same count of carbons, but it's going to be, I guess, 2N, so double the amount of carbons minus 2, because we've added that double bond. And now if we look at polyunsaturated fatty acids, again, so let's just, so C5, so let's just add another fatty acid here. Oh, sorry, let's just add another double bond. So that means we have to, I guess, remove some hydrogens here, remove this one, and let's just remove this one. So you can see now we removed another 2. So hydrogen count is now 6. And O2 is still the same. So that's if we've added 2 double bonds to the system. So for polyunsaturated fatty acids, carbon count is still the same. You still do 2 by the time for hydrogens, 2 times the number of carbons, but you subtract 2 times the amount of double bonds. Because it makes sense if you count now, there's 1, 2, 3, 4, 5, 6 carbons. So let's do it. So if we do, we've got, sorry, 6 hydrogens. If we do 1, 2, 3, 4, 5 carbons, so that means we're going to have hydrogens, we're going to have 2 by 5, so 10 minus 2 times 2. So 10 minus 4 is 6. So it's the same if you had 3 double bonds. So remove a hydrogen. Same deal. You're going to have H equals 4. And if you do the equation, so it's going to be 5, 10 minus 2 times 3. So 10 minus 6, H is 4. So if you use this, these kinds of formulae for these types of questions in the GAMSAT, you can definitely streamline answering a question. So if we take a look at the first question, question 32, is this asking a group of 3 fatty acids that are all saturated? If you look at the table provided in the unit and you just assign using these formulae, you'll find that the answer has to be A. So the answer is going to be A. So it's going to be capric, stearic, and cirrhotic acid based on these formulae which we've used or derived. So if we move on to now question 33. Question 33 is, I guess, the same principle. Just use the equation. In the last question, we used this equation or this formulae. This question now is asking us to use this formulae because we're looking for arachidonic acid. So arachidonic acid, if we look through the table here, don't get confused with arachidic acid. So arachidonic acid is just above. So arachidonic acid is here. It's just above. Actually, sorry, we're not going to use this equation. We're going to be using this equation. So for polyunsaturated fatty acid, because you would have found that arachidonic acid has 8 less hydrogens than there are carbons, which means if you straight away intuit, there's going to be 2, 4, 6, 8, 4 double bonds in arachidonic acid. So you know the question for the answer for question 33 is going to be D, 4. So if you still can't conceptualize that, write it out and you'll see for yourself. I mean, I don't want you to draw it out because it'll take you probably forever. But I mean, if you draw it out if you want, but you'll see that just by using this formula, you'll get the answer. Just by eyeballing it as well. If 2040 is going to be saturated and then you've subtracted 8 hydrogens, that means you've got 4 double bonds. So that's how I'd look at it. So that's question 33. If we move on to question 34, it's asking us what change would you make to the polyunsaturated fatty acids to increase their melting points so that we can make them into margarine. Now, in the stimulus, we were told that saturated fatty acids are solid at room temperature, or they're semi-crystalline at room temperature, because they can pack closely together to make, you know what margarine is, right? So margarine is that nice butter. It's that hard, fatty substance. So they can pack together very tightly. And that's because if you think about it intuitively, they don't have double bonds. Double bonds would make something, a structure, rigid, which means they can't pack closely together, which is why if you see that monounsaturated and polyunsaturated fatty acids are usually liquids at room temperature, because they have those double bonds that make the structure rigid, which means they can't pack tightly, which means they're more likely to be liquids at room temperature. So straight away, just by looking at this question, you know the only way or the best way to, I guess, increase melting points or to make the structure more solid is that you have, if it's a polyunsaturated fatty acid and you want to make it more solid, so it's going to be liquid. So we start off with liquid polyunsaturated fatty acids and we want to make it more solid, we have to make it saturated. So remember, if we saturate the molecule, so we remove double bonds, we're going to make sure that they pack tightly so that we can make a solid. So straight away, just by eyeballing this, you know that the answer is going to be C. It has to be C because we're reducing the number of double bonds, which means the structure can pack more tightly. If we take a look quickly at the options there, it can't be A because pH has no effect on the melting point. So we know that's wrong. B, adding alkyl side chains. Look, side chains could increase melting point, but in this instance, it won't, because if you add more side chains, it's going to lead to more bulk, more steric hindrance, and they're not going to pack tightly together. Again, it's going to mean it's going to reduce the effectiveness of forming that nice, thick crystalline margarine structure. So it can't be B. And if we take a look at D, reducing the number of carbon atoms, again, polyunsaturated fatty acids have lots of double bonds. Even if you reduce the carbon number, they're still going to be rigid. So reducing the carbon number isn't going to change the rigidity of the structure. So we want something that can pack tightly. So the answer can't be D. That's why the answer is C. So if we move over to the last question now, question 35, again, same principle with using these equations. We're told that the iodine value and which one is going to have the highest iodine value, so either capric, gatic, or arachidonic acid. So if you use these formulae, you'd know that arachidonic acid is a polyunsaturated fatty acid. Our gatic acid is a monounsaturated fatty acid, and the last fatty acid in the list is our capric acid, is a saturated fatty acid. So therefore, you know that obviously the more double bonds in a system, the higher the iodine value, and therefore arachidonic acid is going to have the highest iodine value. Capric is going to have the lowest because it's saturated, there's no double bonds. So your answer is going to be D. So if you're having difficulty, you can, if you want to ask any questions, you can post them in the comment section below. If you're having difficulty here with the chemistry, I suggest you go back and visualize the structures and how they are in space, and see if you remove hydrogens, how that affects the structure, how it can affect the count of hydrogens, and using these formulae pretty much. If you do want to contact us directly, you definitely can. I'd love to help. But chemistry is something that doesn't come overnight. You just got to keep practicing. But look, we're here at the Institute of Medical Education. We're here to help, and we're available anytime. Thanks for your time. Take care. Bye.